I'm providing instruction for if you love me, let me know. Before you begin trying this problem set or looking at my video, make sure you've read this introduction here. It talks to you about what we're trying to accomplish, it talks about ion swap reactions, talks about precipitates. Read this first. I'm doing number 3 so you can check your work. Potassium carbonate, K2CO3. Reacted with zinc acetate. Since it's a reaction, this salt must be aqueous. The zinc acetate is Zn for zinc, parentheses, C2H3O2 for the acetate ion. There need to be 2 acetate ions. That's also AQ if I want a reaction. Arrow means change will occur, chemical change will occur. I need the products now. One of the products will be zinc carbonate. Zn is +2 ion. Carbonate's a -2 ion. They can bond together to make zinc carbonate. That is a true bond, inseparable. It is an insoluble salt, so I write solid here. The last product will be potassium acetate. Potassium is a +1 ion. Acetate is a -1 ion. This is the correct formula for potassium acetate. It is a soluble salt, so AQ. You will need 2 copies of potassium acetate. So this is called a coefficient. This is the correct equation for the reaction. The precipitate is here. The insoluble salt, zinc carbonate, is the precipitate. So if you have this, you have the skill to do these equations correctly. I will show you how to get this if you said, I need some help. Here's how I got to this equation. Potassium is K from the periodic table. It's a +1 ion. Carbonate is a polyatomic, so I'm making a big circle for carbonate. CO3, charge is -2. So here, this is why I know I need a second potassium ion, so that I have 2 positives, 2 positives to go with the 2 negatives here in the middle. That's why it's K2CO3. The zinc is on the back of your periodic table is listed as a +2 ion. So zinc is a +2 ion. Acetate, again, is a polyatomic. Big circle, C2H3O2, with a -1 charge. So you should see the need for a second acetate ion, C2H3O2. Oh, that entire group has a -1 charge. This is the ionic bonding picture here for zinc acetate. On the other side, the zinc ion is +2. It will be attracted to this carbonate ion. If that attraction is strong, then they can form a precipitate. And you can see on your solubility chart that zinc carbonate is insoluble. That's what makes it a precipitate. That indicates that their bond is strong. So that will mean that I draw those 2 ions bonded together. Zinc is a +2. Carbonate is a -2. You can see I only need 1 of each, so that's why it's as simple as ZnCO3. The last part is tricky. The potassium is a +1 ion. The acetate is a -1 ion. So although it's big, it's just a -1 ion. So here's a plus and a minus. That's done. It's KC2H3O2. That is the formula. But you will notice that comparing to the left, there are 2 acetates, therefore I should end with 2 acetates. They don't bond to each other. There's no bond here between the acetates, and therefore it is appropriate that I draw a picture like this and say there's a potassium acetate, 1 copy here and a 2nd copy here, and that's what this coefficient of 2 here means. There are 2 copies of potassium acetate.